this means is your application should consist of at least two files, two VI files, one for the client, the other for the server. So the client file is what we already described here. This part is the client file. So this is the part that the users of the car wash system would directly interact with. Then, in the background, there should be a server that is listening for information coming from that particular client. The data that should be imported should be the date, the time, and the type of wash. So the log file should be stored in a location relative to the location of the car wash system. And I showed you how to do relative file paths in one of the previous activities. And that's basically it. So yes, you must have TCP/IP. um, the server should be a separate file from the client, and the server receives information from the client and then creates this log file that can keep track of what is happening. Is that clear?
Yes.
All right.
Is it compulsory to have the date and time as two separate values? Like, is it okay if my version of the logging system has a date and time as one value?
Okay. Generally speaking, this shouldn't be an issue. However, remember for the marking criteria, if you take a look here, if I can zoom in a little closer, you have what we call programming style, functionality, user interface design, and conformity to design standards. So when you look at something like programming style, you're looking at the student's ability to be able to produce code that is not only functional, but elegant. Elegant code means code that is efficient. If I were to say create a system where all of these information is kind of bundled into one block of data, what that would mean is I wouldn't be able to sort based on certain criteria. So, for example, imagine I have a complete file listing out all the types of car washes for 2 or 3 months. I won't be able to look at day to day what's going on because everything is just one block of data. So, sorting through the entries and searching through the entries becomes a little bit more difficult. So a student who produces a system that classifies and categorizes these data pieces as separate entities would have done a better job than one who bundled everything together. You see what I'm saying?
Yeah, got it.
So you will have more programming style points as opposed to somebody who just lumped everything together. Any other
Got
questions,
it.
people? Mm.
I do have a few more.
All right, go ahead.
All right, so in one of the recorded classes of the previous batch, I heard that you mentioned about pseudocode of the entire program. Do we need to do that as well?
No, if you look at the outline, I shared with you a document called the outline of the in-course. You will see the most important bits here. You can rearrange this, by the way, but these are the most important bits. The marking criteria for your assignment has two main classifications, what we call design and implementation. So this document you're submitting the report is the design. It's supposed to just detail what was done and why it was done the way it was done. It begins with a proper introduction to the assignment case. In this case, the assignment case is basically a car wash. So you would need to define, express explicitly what a car wash system is, the different types of car wash systems that exist, what are the advantages and disadvantages or shortcomings or dangers of the operations of a car wash system as the introduction. This is the background. So about car washes, how they operate, what goes right, what goes wrong. If you have any assumptions, these assumptions are what helps you polish out the nitty-gritty details of the implementation. So like I mentioned, the assignment question goes ahead to give you the minimum requirements. Anything else you want to add to those minimum requirements, you're perfectly welcome to do so to make your work a little bit nicer. So if you don't have any assumptions, this section will not exist in your documentation. The only person who
I
should
say,
have,
excuse me.
yes,
Sorry, could you please start recording this session?
Okay,
Thank you, sir.
you're welcome. So we're waiting for the recording. All right, the recording has begun. So I'll just do a quick recap. So as I was mentioning, with regards to the contents of the submission of the in-course assignment, there are two components that we're grading. We will be grading the design and the implementation. For the design, everything is within this documentation. You begin with a proper introduction of the assignment case, which in this particular case is a car wash system. So you would introduce what a car wash system is, the different types that exist, how they operate, what are some of the dangers or concerns that anybody building a car wash system should be aware of in terms of damage, in terms of operation, damage or risks in terms of operating this particular type of facility. The assumptions is basically you adding detail to further define or justify your implementation. Whenever, as a software developer, whenever you're giving a project, there are certain pieces of detail that may not necessarily be given to you directly. So you have to make certain assumptions. It's not necessary for you to make assumptions in this assignment. You can take a look at everything that is the minimum requirements and decide to implement it well. You're good. The only reason why you would have an assumption section would be if you added or you thought or you saw some loophole inside the entire case and then you had to kind of fill in the blanks. So the assumptions are basically just single statements that says I'm assuming I'm approaching this project assuming X, Y, and Z factor exists, therefore I'm going to be doing ABC. So ABC exists, I'm going to do X, Y, and Z. Then when you get to the system design, you will notice here I separated into client server. This means you have to discuss the system design of the client separately from the system design of the server. In other words, I need both. You want to lump the conversation into one particular paragraph, you're welcome to do so, but you must explicitly discuss the client as well as discussing the server. So here are some of the suggestions of the contents of the system design. Whatever you do here must directly match the implementation you've made. There are cases where we've marked down students who basically provided either a incomplete design document or they submitted a design that was not congruent with the implementation. So you have to make sure what you have here defined on paper is how you actually implemented your work. So you typically begin this with a storyboard. The storyboard details every scenario of operation, if you like. So from the very conceptual start to the very end. So this is where you might start thinking of assumptions. So imagine this is a car wash system. A person drives through. The very first thing that they need to do is make some sort of transaction. In other words, they need to select a type of car wash. You have to envision what mechanism they're going to use to do that. According to this program, if you look at the question, the program gives a very rudimentary interface. They're just these two buttons. So what would the presentation of these two buttons be in your own implementation? You might decide you want to change the layout. You might decide you want to even add some confirmation. You might think to yourself, this is going to be on some sort of separate tablet. So there will be an interface that just is designed for the selection. And then inside the car wash itself, there will be some sort of notification screen that shows these car wash indicators, in which case you will have all of these components, but these components will be separate. So you could even have them on completely separate VIs, but all interacting with each other. So this is where your assumption case is. So a student might decide to design it exactly as seen. Another might decide to partition it. So this part will be on one app and another part will be on another app. And the car wash simulation switches will also be on another app. Whatever tickles your fancy, you can go ahead and basically have that freedom in creativity. So the storyboard just simply allows you to explore before you begin building how the process is going to execute from start to finish. So you're going to be drawing, you can use stick diagrams, you can use images of the internet, you can use applications to design this. Essentially, you want to just show the different scenarios. So a storyboard is just an image of something occurring with a description following. That description will then allow you to create what we call use case diagrams. So a use case is basically the different cases of use. In other words, if my application had 10 functions, my use case diagram would have defined those 10 functions. Basically, a list of every single thing that my application is capable of doing. And those will show the relationships and the dependencies. So your use case diagrams should come together with use case descriptions. This is all part of system design. You've done courses that cover this. Then you follow that up with activity diagrams, etc. In other words, these are minimum requirements. Any other thing you can add in terms of software design, documentation, or description, you go ahead and include it. Once that's done, you move to protocol design. This is your communication model now. This is specific to the question of the file login because that's the only part that really involves the client server architecture to be implemented, the TCP/IP particularly. So you will be showing how your client communicates and transmits data to your server. So that's this bit. So you'll be showing the relationship between the client server over a TCP function and how the data has been basically formatted. And then based on last week's class, lecture class, you'll be looking at health and safety considerations for a car wash system. So this is going to require some research on your part. In other words, what are the different health risks that are in that can be found in operating, running, and participating in a car wash? So when building the system, you're envisioning at the end when it's implemented, what can go wrong? And in a typical car wash system, there will be two types of customers, if you like. You'll have those people that are actually operating the car wash, and then you have those that are the customers of the car wash. So looking at it from these two perspectives, what can go wrong? You make a list of all the things that can go wrong and how those uh, how those health risks or general risks can be mitigated based on lesson uh, the lesson from last week. So inside the discussion last week, there were a couple of steps that you could follow in order to extrapolate these risks and how you would go about mitigating those risks. And they have 4 steps. If you go back to the video, you will see where I describe the 4 basic steps of creating a risk assessment document and tackling or mitigating these health risks. And finally, you have implementation. Here you just need to create a table that contains a list of all the necessary hardware for the physical implementation of a car wash system. So if you look at the design of our car wash, you would need to make a list of all the different hardwares we would require and basically a description of all the hardware pieces to actually build and implement a for real hardware, a for real car wash system. So your software is going to be controlling all this hardware. So all you need to do is a list of hardware. And when I say a list of hardware, here you have a proximity switch. What type of proximity switch are you going to use and what is its description? So you would go online and look at different types of proximity switches. You would then determine which one would be suitable for implementation in your own car wash system, and you're going to give us a table with its specification. That is its name, its price, and its functional characteristics. So it's going to be a table. Same thing with this water pump, this water jet sprayer, this blow dryer, and all other components, the pressure plates here, everything that is based on your design, every piece of hardware, the screens you're going to be using, for example, for these LED indicators. Are you going to use a digital screen? Are you just going to use LEDs? What exactly? So you need to come carefully and look at your entire build and determine what pieces of hardware. After that, there's a conclusion section that allows you to critique your own piece of work. So you look at the limitations of your build and other considerations with regards to the build, and you just jot them down. What your system does well and what your system doesn't do particularly well, which leads you into the next section, which is future enhancements. So if you look at this entire documentation, really the parts that I'm really interested in is the system design and the protocol design. This just gives you a description of what the student built. This is very important. And the actual work is in the health and safety and the implementation. So really, this part you're going to do research. This part is what we say it's descriptive. You've designed the application, you've built it already, you're just documenting that design process. What is the architecture of my application? That's this. It's not brain work, it's descriptive. The actual research is this. So this is what I will be looking at critically, these two sections. Here, I'm just going to make sure your design matches your build. And then under health and safety consideration and implementation, this is where the points come in. So once you submit this, then I grade this, then I take a look at your actual software. If your software meets minimum requirements and it functions, then we begin looking at the marking criteria over here. So programming style will determine how well your architecture build is. In other words, how efficiently you've coded your work. Functionality will be determined by if you've been able to implement every single function appropriately to specification. User interface design, if you've been able to design a user interface that is creative, functional, and practical. So imagine if I was building or determining what type of interface to build for this car wash system, I need to consider that the car wash system is going to be an outdoor application. It's going to be something that is used outdoors. So I have to take notice and consideration to the type of audience that is going to be using it. A car wash system is going to be used by all different classes and calibers of people. It's going to be based outside. A person is probably going to be sticking their head out and their fingers out of their car whilst operating this particular system. So a student who builds an interface that has large buttons that are easy to see with high contrast and easy to press will get more points than say somebody that just builds something regular. So keep that in mind. So that's how you get points for this. Then conformity to design standards. This is in the code if you've been able to document your code appropriately. Remember, whenever you build a piece of software, there is the likelihood that the project is going to be in real life be built by several people. So when you're building a component, you need to add code commentary. You need to use appropriate controls and indicators. You also need to make sure you're using the most appropriate data types for capturing and storing information. So generally speaking, conformity to design standards is looking at software engineering principles that ensure that whoever is opening your code and taking a look at it, it's done in a standardized format. So it will be easy for them to understand what it is you did and how to troubleshoot or fix or update whatever it is you've actually implemented. So this includes naming, using a naming of the variables, using appropriate data types, using appropriate controls and functions, and setting up the application with commentary and so on. So that's all part of conformity to design standards. So this I will be checking in your block diagram. And then of course you have the documentation itself that we mentioned, which will the key areas will be the system design and the protocol design, as well as the health and safety and implementation. This carry the bulk. The health and safety itself is what carries the bulk of the grade. This part, like I said, is descriptive, shouldn't be hard. So that's that. Any other questions?
Yes, I have a question.
Go ahead.
So under protocol design, when you were talking about TCP/IP, right, you mentioned that that is primarily related to the file logging system, correct? Like logging each successful car.
Yes.
But in prior classes, you also mentioned that since there are two users, it would be useful to have a login system. Does that mean that if we were to implement that, we have to also discuss that in the TCP/IP section?
Very good question. So when I mentioned that you could have a file, a login, apart from the file login, you could implement a login process. I was actually talking about assumptions and a little extra. You see, the work given here in this assignment is very basic, very straightforward. Build a car wash system. Now, inside this build, you're required to create a file login. The assignment question does not determine or ask you to make that logged file viewable. It doesn't say that. It just wants a server that creates a text file that shows transaction date, time, and type. So I was giving a suggestion for those of you that want to improve your score. If you followed the exact description of this assignment and you implemented everything this assignment said the way it said, you're getting guaranteed a C, right? You're getting 50% guaranteed if you do everything exactly as said. Now, if you put in a little extra, you move from that C to a B and eventually to an A. So how do you get an A? By implementing what was asked more perfectly. So in some cases, you may actually need to think outside the box in terms of your implementation, that you not implement something that works but is practical. So I gave a suggestion. I said, for this file login particularly, imagine a student who just builds an invisible server file. There's no interface design on the server, but it does the job of documenting, collecting information from the client, and then creating this file. That's a pass. That's a C. And another student who thinks to himself, all right, since I'm going to build a server that's going to do this, wouldn't it be nice if I could actually permit the second customer, which is you could call them the administrators of the car wash system, to be able to view these details and to be able to make it searchable. So if I'm going to build that kind of interface where people are going to be interacting with data, I might then think to myself, oh, since I'm going to be dealing with this data, why not implement some sort of user logging system? So an admin would go to the server when the server runs, maybe punch in a username and a passcode, and then the system will reveal all the data and they can search through. If you want to even go the extra mile, you could even have a graph that shows sales purchase based on days, based on months, based on year, whatever tickles your fancy, just to show your programming prowess, how familiar and comfortable you are with this lab view. So those are extras, right? Those are extras. I hope that makes sense.
All right, thank you, sir.
Yes. Any other questions?
Yeah, are we allowed to use any sub VIs that are generated by the NI community?
All right. You'll see in the very beginning of the description, it says no templates are allowed. Anything you take from the internet are completely prohibited. However, if you see an implementation of a particular function or a style of coding, you are permitted to reproduce it. That means take a look at the thing, download it, experiment, play around with it, and then rebuild it in my own customized form. That's perfectly acceptable. But to take it as is and insert it into your application and do citation and referencing, that the assignment specifically says you shouldn't. You should just make use of a vanilla installation and you should not have any dependencies. And here's the reason why. You might think that rule is arbitrary or confusing. If you implement or import a particular sub VI that you didn't design, that VI might have certain dependencies. When you run it on your computer, it runs fine. But when I put it on my computer will need to maybe download some components that are not in the vanilla installation. So what that ends up doing is breaking your code at grading time. When you downloaded the particular code, your installation of LabVIEW might have automatically downloaded those dependencies. But for me, when I'm running it, those dependencies might need to then download, which means your application will be broken until and unless I download those. And in some cases, the servers are not always available, and it's just an overall hassle. So that's why we encourage you to use your own code. If you find something online, an implementation you like, you just reproduce it to avoid that dependency problem. And then you're good. So rebuild, don't reuse. Rebuild. Any other questions? So this is the point I was referring to just now. Any other questions, people?
Yes, sir. So you mentioned that if we want to go above and beyond to get better scores, we should add more features which are not included in the question. That makes sense for the application, right? Is there a
Yes.
section where we can just list down these additional features so it's clear that these are things we created that are not in the question?
Yes, we already discussed that. Limitations, considerations, and future enhancements. So here, what you essentially have is a critique of your work. So I listed out these limitations and considerations. Limitations are the shortcomings, considerations are the extras. You follow? So you need both when you're criticizing.
Yep.
You're going to say, here's what I did right. Those are my considerations, the extras, and here are the limitations. Those are the things that, despite our best efforts, they're still risks, if you like. They're unavoidable risks, which you would have derived from your health, or partly derived from your health and safety considerations. So it's already there.
All right. Thanks, sir.
Yes. All right, so I'm hearing the session's kind of slowing down. I think we've addressed most of what we need to. Let me give you one last quick checklist reminder of a few very important things. Your submission. Um, we've already stated that this piece of work consists of two main components, your design and your implementation. Here on Moodle, what you will be submitting is both your design and your implementation. So please listen carefully. Your submission is going to be done via Moodle and Teams. And here's how I need you to prepare your files. Your actual documentation, this Word document that we've been looking at here, this documented work, should be submitted as either a PDF file or a Word document file on its own, unzipped. Then the application, your implementation, your actual software, all of the files should be zipped, which means when you're submitting on Moodle, I'm expecting to see two files, a document, a Word document or a PDF document, preferably a PDF, but Word documents are allowed. So a document and a separate zip file. Now, when I say zip file, I mean zip file. If you have applications like WinRAR, when uh, you're compressing your files, make sure that WinRAR is set to producing it as a zip file. It should be a .zip, zipped. So everything related to the application, zipped. The documentation should be not included in the zip file, but as a separate entity. So there will be two separate files on Moodle. Then on Teams, I've created an entry for you. So if you see your assignment section, there's a section called video presentation. So this video presentation, you need to record a demonstration video. Now, there was a group that just finished recently this particular module, and a few people, very few people, uh, basically implemented their videos a little wrong. So I wanted to quickly address those. Importantly, your video should have two sections. One, demonstrating that the code or the build is working. So it means when you begin your video presentation, you introduce yourself, you should be in view. You should try to get your face on the video. Then you should go about demonstrating the application running. So I've built this app and it's running, and here's it running. So what I would expect to see from that video, the first part, is your interface running and you demonstrating a deluxe wash and an economy wash, and then showing me the file login on the server. Basically, everything you've done, you show it to me running real quickly. The second part of the video will require you to open up your block diagram and then explain your code. What you did that was generally your approach, what you did if you did anything special, what you found challenging, just the most interesting bits of code you want to show. Remember, the whole point of the video is I don't believe you did the work, and you are trying to prove to me that it was I that did this work. Every single thing you see here, I did it and I understood what was done. That's the point of the video presentation. So I'm not going to be grading your appearance. I'm not going to be grading your presentation skills, as it were. All this video is doing is demonstrating to me that the application works, how to run the application, and that you understood what was done. That's the only point of the presentation. The presentation itself is not graded. Before I grade your assignment, the presentation video has to be there to prove to me you did the work. Once I'm convinced you did the work from the way you're explaining the code, then I look at the actual code. And it is the actual code that I'll grade. So the presentation, 0 marks. It doesn't carry any mark. But if you don't do the video presentation, I'm not going to mark the assignment. The assignment basically becomes a 0. So you submit the video presentation describing the code and showing that your application works. Then that gives you the green light. That gives me the green light to go ahead and mark the actual piece of work. And when I'm marking the piece of work, I'm going to be marking it based on these first 4 criteria: programming style, functionality, user interface design, and conformity to design standard. The implementation document, the document we just talked about, that's this guy. So if you look at the breakdown, this documentation is 20%. But the actual piece of software, conformity to design standards, 10% of the grade, user interface design, another 10%, functionality, 30%, and programming style, 30%. So let's say in a situation, a student implements roughly okay programming style, so they get pass. That's 50 out of the 30. Then for functionality, they build the application, minimum requirements met. That is another 50 out of 30. So they already have 30 points. Then for user interface design, let's say again, they didn't do anything fancy. They just built it like the assignment question showed. So they're getting a 5 here. So what you now end up with is 30 plus 5, that's 35. And for conformity to design standards, let's say it was rudimentary, they get another 5. So that's 40. And then the documentation, they just did basic. So that's 10. So that gives you a total of 50. So if you do everything basic, you just get a pass. Anything you do a little extra for any of the sections, here is the weightage and how it affects. So if you did your documentation very well, you did proper formatting, proper citation and referencing, it was very detailed, you really went ham on the health and safety issues, you identified several points, and then you expressed your design properly, you get an A. Just for this, so you get your 20 points or close to the 20 points. If you really followed the design standards, again, you get the points. If your user interface was really considerate of the type of application you were building, you get your points. If your functionality, everything was spot on and your efficiency was there, you get full marks. And then if your programming style implements sub VIs as well as nice little tricks for code reusability, you get extra points for that. So this is how it's going to be graded. So once again, the video presentation must be done. In the video presentation, it should not be more than 10 minutes. Your video presentation should not be more than 10 minutes. The first part of your video presentation should be you demonstrating the application running, just the function of the application, that everything is working fine. That you should be able to do in less than 2 minutes. You turn on your video, you introduce yourself, You begin the presentation. Here's my application running. Let's start with the deluxe case. I press this button. Here's the application functioning. If I pause or the vehicle is out of position, here's how the error warning pops up. Everything. You just show how your application runs. 2 minutes, 3 minutes, you should be able to do that. The remainder of the 10 minutes, you can then go into your code and start describing your code. Your goal is to show me that you built it and you understand how it works. That's all. If you're able to do this, then I proceed to marking your document. So I hope that's clear to everyone. People, I hope that's clear to everybody. If you have any other follow-up questions, now is a good time. All right, can I get a thumbs up if everybody is satisfied with the assignment requirements and the description? All right. So the next thing is the test. I already made an announcement a couple of months ago regarding the test. You will see on your Moodle page, there is the test. It's test 1 and 2. Both tests will be done together one time. So test 1 and 2 is going to happen uh, the day after the submission. So that's 8th March, 10:45, between 10:45 and 12:20 p.m. So that's basically our lecture period. So we're going to be able to do it in 2 hours. The test 1 is going to be a set of 20 multiple choice questions, 20%. And the test 2 is going to be one single question similar to your quizzes. Those class quizzes that you've been doing, it will be similar to those class quizzes. It's going to be a small mini project. So what you need for the test 2 is basically an installation of LabVIEW. What you need for test 1 is nothing. Everything is theoretical. It's just multiple choice. I'm going to give you a couple of questions and you're going to provide me with answers. Now, primarily, the test is going to be very lab view focused. It's going to be very practically lab view focused. You'll notice in our entire semester, most of our actions has revolved, or most of our teaching has revolved around the LabVIEW software. We've had situations where we've actually talked about separate topics. For example, when we looked at logic gates, and last week when we looked at the health and safety. So we have a little bit of theory sprinkled out throughout the module, and all of those will be covered in the test. So keep that in mind. But fundamentally, the vast majority of questions are programming in LabVIEW related. So if you've built your assignment and you've done your quizzes by yourself, you really have nothing to worry about. We're just going to be showing you code functions, and we're going to be asking you how to determine the outputs of certain codes. If there's an error, how would you correct the error? Basically, programming questions. There will be a few theoretical questions based on some of the parts of the topic that we've covered. For the test 2, it's just build this application in 1 hour or less. So you have to be able to build it and finish it up in an hour or less. So all in all, the 100% of the module, 20% of it is class test 1, 20% is test 2, 20% is the quizzes. So just those 3 components is 60 points. Then this in-course assignment that we're talking about now is going to be the rest of the 40%. But we're grading that 40% as 100. So this 100, again, remember, programming style is 30% of the 40. Functionality is another 30% of the 40. User interface design, 10% of the 40. Conformity to design standards, 10% of the 40. And documentation, 20% of the 40. So that 40% of the in-course is going to be exploded into 100 points. We mark and then we scale it back down to the 40. So the actual assignment is just 40%. Test 1, 20%, test 2, 20%, and the quizzes, another 20%. So which means passing this module is fairly straightforward and easy. You begin with already 20 points. If you've done all your quizzes, that's a guaranteed 20 points already. So you're just working for the rest of the 80 points. So it shouldn't be too challenging for you. So if you have any questions regarding the test, let me know. The test is going to basically occur next week, Tuesday. So tomorrow, in tomorrow's session, uh, we could look at some of the details of the test. We could look at the test in more detail. If you have any further questions relating to the assignment, we could also take a look at those questions related to the assignment. So what you want to do tonight, before the end of the day, is to basically streamline, format everything that you need to do with regards to the assignment. Tomorrow is going to be your last chance to ask questions, after which I'm going to leave you alone. So on Monday, you're going to be working on really submitting the document. So I'm only going to come to class to listen if there's any like real quick polish issues that you just need to just iron out immediately. I'll imagine on Monday everybody will be busy trying to finish everything. So I'll make myself available only to just rectify simple issues. If you have any serious issues, tomorrow is the time to do it. Then on Tuesday, next week, we're going to be engaged in the test. So all you need is an installation of LabVIEW functional. I'll deliver the questions. It will be done on Moodle. So you will have about 10 to 15 minutes to do test 1 and 1 hour to do test 2. So everything should be, we'll be able to finish everything in about 2 hours, the 2 hours of our allocated time. And that will be that. Then you'll enter your revision week, which you will then begin to prepare for your other modules. Any final questions, people?
So I have a question in chat box. Can you check it out?
Go ahead.
It's in the chat box right above the one you're seeing right now. Yeah.
So that's all right. So you say regarding the main cycles here, let's see the image. Main wash position switch verifies the vehicles in the correct position for the wash cycles 2, 3, and 4. To operate, each cycle should last for 5 seconds if the vehicle rolls off the main. So what's your question exactly? You say it says each cycle for 2, 3, and 4 should last 5 seconds, but here it says 5, 5, and 7. So it says it should last for at least 5 seconds, except if otherwise stated. So that statement should be unless otherwise stated. So if your question is what should you implement, what you should implement is this. If you take a look here, this is what you should implement. So in the question, it says everything should last for about 5 seconds. Let me find the actual position. Yeah. For this application, each cycle's duration should be set to 5 seconds unless otherwise stated in the operating rules below. You see that? Unless otherwise stated in the operating rules below. So I did a little update to that. So yeah, so this should be what you follow.
But,
Is that clear?
yeah, yeah.
All right. Any other questions, people? All right, so I'm going to go ahead and stop the recording. So tomorrow, again, we will have another chance. Hopefully tomorrow you would come perhaps a bit more prepared if you've worked on a few of the sections and you're still curious or you're wondering about the actual test. We will also be posting our latest quiz uh, just in time for you to be able to finish before the final week is over and you're done with this module. So with that said, I'll see you all tomorrow, God willing. Please come with your questions. I seriously advise you to try and explore everything you need to explore. Tomorrow is really the last day you have for any sort of Q&A. All right, with that said, have a good rest of your day. I'll see you all tomorrow then. Bye-bye.